Hey guys, this is Damien here, and I wanted to give you a quick update on my crash. So when I hit the ground, the feathering shaft, which is the shaft along the head here, that bent as well as the main shaft that goes right through the entire body of this helicopter. So the feathering shaft is about $2, a little over $2. The main shaft is a little over $4. I have spares, so those will be replaced. I ended up purchasing two servos. One of them is because the wire was spliced and the other one had bad servo gear, so I didn't want to chance another flight with two bad servos. And on top of that, I had to buy a tail motor, which, as you saw in my previous video, the wires completely got ripped out of that tail motor, so I had to buy one of those, as well as new servo horns. So the ones that come with the Goose Guy, they are not as forgiving in a crash. These are extremely strong as far as plastic goes. So I ended up buying a different set that fit these servos that are a little bit more forgiving. So if I hit the ground, they will immediately break. So that is the update as far as the parts goes. I think that was going to cost me about $78 to $79. And a big thank you to one of my subscribers that had donated some money to me. Thank you for that. That will definitely be going towards this purchase. And now for the print. The reason I laughed on my previous video is because this thing was absolutely destroyed. And the reason I was laughing at it was because it didn't take me too long to print this. So we'll go through each and every single part on how long these parts take to print, as well as how much plastic you are printing with for each of these parts. But a little teaser for you guys that you won't find out in this video, but in the next video, I will no longer be flying with this 3D printed Goose Guy chassis. I have something coming up in the works, and I can't wait to share that with you guys, but that is all I have to say. This version, I should say, will no longer be used. But let's get to each and every single one of these parts and talk about 3D printing them. Let's go through these screenshots I took. Bottom frames are 2.95 grams, 25 minutes to print per frame. Top frames with the adapters installed is 1.67 grams, 23 minutes to print. That's per piece. Battery tray 4.06 grams at 40 minutes. Flight controller tray 3.89 grams at 37 minutes. Motor mounts 1.48 grams at 21 minutes. Front bracket is 1.4 grams at 16 minutes. Landing gear is 9.24 grams at 1 hour and 14 minutes. Anti-rotation bracket at less than a gram at 12 minutes. The boom is 8.48 grams at 1 hour and 11 minutes. The boom block is 4.38 grams at 56 minutes. And the vertical stabilizer is 2.58 grams at 24 minutes. Now, I didn't end up printing all the parts. The only thing that actually survived was the tail boom and the boom block. Everything else I ended up printing. And the reason the time does take a little longer to print is because of the accuracy that I'm trying to get these parts as far as the hole locations go. So I do print these at 0.1 millimeters. And I do print them at 20%. You could bump that up to 100, and I don't think you'll see a huge difference as far as the weight of the part itself goes. But remember, all the parts on this helicopter are absolutely free on Thingiverse and Printables. You could download them, print them as many times as you would like, as well as replacing any parts that you might need if you have a 3D printer. Now, I'm super excited to release my next version or my next print for my next video. So if you guys have any thoughts or ideas on that, please comment down below and tell me what you think. But if you guys like this type of content, please like and subscribe, and I'll catch you guys in the next one. Thanks for watching.